Hello everyone, my name is Mei Chen. I did my PhD dissertation under the supervision of Dr. Lucius Sobelman. I really appreciate the opportunity and your time for reviewing this video and my dissertation. In this video, I will give a brief overview of my dissertation and show the application where the outcome from my PhD work can help the Army's training and rehearsal in simulated environments. My research focuses on classification and segmentation of photogrammetric 3D data for creating virtual environments. In the first part of my thesis, I started with investigating the photogrammetric data characteristics and designed a framework for semantic labeling of 3D point clouds meshes that are generated with photogrammetric techniques, and extracted the necessary object information such as individual tree locations, building footprints, and ground materials for the creation of virtual environments and simulations. In the second part of my thesis, I looked more closely into the 3D semantic segmentation problem and designed a simple yet effective model ensembling framework, which utilized some deep learning techniques. The designed model ensembling framework is generalizable enough and can be deployed in the real-world application in a fully automated manner. At that point, I also led our research team and established a photogrammetric 3D point cloud database, which contains a total of 22 datasets that cover approximately 10 square kilometers area with about 100 million points. Note that all the points have been manually annotated to create the ground truth for training and testing purposes. Our team has spent about 2 years of effort to collect the data, process the data, and annotate the data. However, the annotations are still limited to large objects such as buildings, trees, and ground. And in the future, if someone wants to use this database for detecting other objects, more annotation efforts will still be needed. This made me think of the question, would it be possible to use synthetic data for training purposes? So in the last part of my work, I investigated the possibility of using synthetic photogrammetric data to substitute for real-world data in training deep learning algorithms. I designed a synthetic data generation framework which utilized the state-of-the-art rendering and simulation techniques and tested my hypothesis. The results showed that the trained deep learning models using the synthetic data would achieve similar performance as if the data was collected from the real world. And it only took 15 days of one person's effort to create the synthetic database. Well, that's a very brief overview of my 6 years PhD life. I also want to point out that my work is part of the US Army's One World Terrain project, and I want to show you a video of application where the outcome from my work is currently deployed. Thank you.
There are a multitude of collection methods, databases, and organizations in the vast geospatial ecosystem. Manual terrain reconstructions can sometimes take months. The fidelity of databases are nowhere near the current rendering capabilities, and the US Army has spent significant amounts of money to generate terrain for training and simulation systems. In this fragmented ecosystem, how do we ensure that decision makers receive accurate, up-to-date geospatial data when and where they need it? The Army's One World Terrain research effort has begun to answer this question. Researchers have achieved this by diving deep into every phase of geospatial data science, from the collection of source data to its final application. One World Terrain research has refined the process into a 5-phase workflow. The first thing a user needs is source data. In the collection phase, a user gets data from potentially multiple sources. This can be anything from still images to underwater topography. Whatever form the data comes in, it isn't ready for training and simulation yet. This leads to the processing phase, in which users work with software to turn the source data into something usable in a simulation. This includes the segmentation and classification of terrain features like structures, road surfaces, and vegetation, which require special handling in a training and simulation context.
One thing that we're doing that's fairly unique is a whole soup to nuts pipeline for collecting and employing this rapid captures of terrain. The other interesting bit is classification to make it operationally useful. It's one thing to have a whole bunch of data. It's another thing to be able to understand what that data means and employ it in the simulation.
Phase 3 is storage. Here, the data has to be stored in a secure repository with permissioned gateways. The repository must also be optimized for distribution to the point of need, which is phase 4 of the workflow. Research in this phase focuses on ensuring that the data is delivered to the point of need quickly and securely. The fifth and final phase is application, in which researchers find and optimize the best applications for terrain tools in decision-making. This workflow supports the ultimate goal of One World Terrain, an authoritative, geospecific 3D representation of the planet that is usable in current and next-generation modeling and simulation systems. Ultimately, the One World Terrain workflow and the solutions created from it will enable soldiers at different echelons with different requirements to experience a seamless, realistic geospatial foundation when executing their training. One World Terrain, supporting the future of Army training.